Hi everyone and welcome to Steering Marinas. In today's video on radar plotting, I will take up a basic radar plot where you have to compile a full report on a target vessel when your own ship's and course and speed is provided to you. So in this case, of course, your own ship's course and speed is 042 degrees true and you are doing 15 knots. And according to the ship's time, at 0640 the target was bearing 351 degrees true when it was 11 nautical miles away from you, and the same target at 0652 was bearing 355 degrees true when it was 7.1 nautical miles away from you. Remember, this is only a single target report, so there is only one target and there is your own ship, and you have plotted or you have noticed that this target is at 11 miles at a bearing of 351, and then at 7.1 miles it is at a bearing of 355 degrees true, and your ship is doing a course of 042 degrees true at 15 nautical miles per hour. So make a note of these information that is provided to you, because now we will shift to the radar plotting sheet and I will show you how to plot a situation like this in the exam and how to derive a report from it. So I'll just go into my plotting sheet and I will do this plotting here. So before I do the plotting, let me just tell you that the scale that I will be using will be 1 centimeter equals 1 nautical mile. So of course it is your prerogative as to what scale you use. You can use a scale that is provided at the bottom of the plotting sheet as well, as I just showed you with my arrow, and otherwise you can use a scale, a separate scale where you measure out 1 centimeter equals 1 nautical mile or 1 minute, doesn't matter, it's the same thing. 1 nautical mile equals 1 minute on our charts. So the first thing that we can do without much delay is that plot the center of the plotting sheet and call it C. Right, this is the center of the plotting sheet, and then we draw the course, our own course of 042 degrees true. So what you can't see on your screen, of course, is that I am orienting my parallel ruler, passing the ruler through the center of the plotting sheet and orienting it in the direction of 042, going towards northeast, and of course 222 going towards southwest. The reason I do that is so that I can get the accurate course drawn on the plotting sheet. So what I'll do is I will draw this. Sorry, my hand is shaking a bit. I want to make sure it. So this has become a bit of a thick line. So I will draw this again. And my hand was shaking in this case. I wanted to do a good job, but in doing a good job, I have kind of started shaking. So I'm not going to shake anymore. I'm going to just draw it confidently here. So remember, depending on how thick your pencil is, how thick your lines are, what kind of scale you have chosen, your answers may differ slightly from mine or from the one given in the book, but don't worry about that. As long as it's close to the answers, it's good enough. So let's see what answers we get in this case, but don't worry about it. This question is actually from Captain Subramanian's radar plotting book. That's why I mentioned the word book. So some of you may be referring to it and you may have seen this question. So I'm just using it as an example so that you have something to compare it to. All right, so I have drawn this in the direction of 042 degrees true, and this is my ship's course. That's the first thing I've done. The next thing I will do is I will plot the target at 0640 at a bearing of 351 degrees 04. So I'm orienting my scale right now at 351 and it's 040. Now remember, my scale that I've chosen is 1 centimeter equals 1 nautical mile. So I need to plot 11 centimeters on it. So I might have to go out of the because I can't show you the full page here. When I did the plotting on my on the paper, I could use a scale of 1 centimeter equals 1 nautical mile so that I can show you the plotting. What I will do is I will change the scale here. I will change my scale here to 1 centimeter equals maybe 2 nautical miles. All right, and if you wish to do the same you can, but because I don't have the full size paper here, so I can just show it to you what I'm doing. All right, so what happens is that you have to half all the distances then if 1 centimeter equals 2 nautical miles. All right, so what we'll do is that we will plot our first target. So our first target will be 351 degrees true, going towards 351. Okay, let's plot the 351 and at a distance of 11 nautical miles. So depending on what scale you have chosen, if you have chosen 1 centimeter equals 1 nautical mile, then you have to plot 11 centimeters away from center towards going towards 351. Otherwise, in my case, I have taken 1 centimeter equals 2 nautical miles, so I will plot half of 11 and I will measure out 5.5 centimeters, which is half of 11 nautical mile. One, so 1 5 2 3 4 5.5, and I will plot it here. So you can see here this dot here represents the letter O. This is the origin. This is when I got my first plot at 0640. The distance OC signifies 11 nautical miles. Now because I have chosen a scale of 1 centimeter equals 2 nautical miles, this is 5.5 centimeters, 5.5 centimeters, which in my case denotes 11 nautical miles. If you have chosen a scale of 1 centimeter equals 1 nautical mile, you should be measuring out 11 centimeters in the direction of 351. And the first plot is called O, that is the origin plot. At this stage we don't have much information about the target, so it is not of much use to us. That's why it's called the origin plot. Then I will measure out the second not measure out, but I will plot the second observation, which is 0652. So remember, this is O is at 0640 hours. So 0652 is 355. So I will orient my scale 355 going from C, and I will measure out 7.1 nautical mile depending on my scale. So because my scale is 1 centimeter equals 2 nautical miles, I will have to measure out 7.1 divided by 2, 3.55, which is kind of hard to get, but you guys know what I mean, so we'll do the best. So our answers might differ slightly, don't worry about it. As long as we've got the process in hand, that should be good enough. All right, so I'm going to measure out 3.55. so I've got 2 and 3. So this is and this I will call as A. So what I have done is that I have plotted 0640 and this is 0652 hours. Alright, so I have plotted OA. So these are the two plots, or these are the two observations of the target at two different times. I'm going to join this line, and I'm also going to use a different color pen because then you don't get confused. So what I'm going to do is I'm going to join these two dots and I'm going to extend it so that it crosses my original course that I drew, this one here. All right. Then what I will do is that I will plot my ship's course going in reverse from O. I'll show you what I mean. So you have your ship's course 042, right? You have your ship's course 042 and you take 042, orient your parallel ruler in the center in the direction of 042 and 222, which is 180 degrees away from 042, and then you move it in such a way that you reach the point O. From O you draw the ship's course but going backwards or reverse or 180 degrees towards away from 042. So you draw it in the direction of 222, something like this. Alright, so you can see this direction that in which I am going is 222 degrees, which is 180 degrees opposite to 042, the course of my vessel. Alright, and what I will do is I will know that my ship's speed in 60 minutes, my ship is doing 15 knots, alright, 15 nautical miles. But this plot is for 12 minutes. The first observation was at 0640 and the next observation is at 0652. So 0652 minus 0640 is 12 minutes. So this makes it a 12-minute plot. So that means I want to know how much will my vessel do in 12 minutes? How much speed or how much distance will my vessel cover in 12 minutes? So in this case, you just do a cross multiplication. So your vessel will do 12 by 15 divided by 60, which is nothing but 3 nautical miles. So your vessel will cover 3 nautical miles in 12 minutes. So why I need to calculate that is that I will measure out 3 nautical miles on this line that I've just drawn from O, which is the reciprocal of my course, and I will measure out 3 nautical miles. So of course, if you have taken a scale of 1 centimeter equals 1 nautical mile, measure out 3 centimeters. Otherwise, in my case, I will measure out 1.5 centimeters, and this is the point that I will call W. Alright, so I kind of extended it because I didn't know where, so now I've shortened it. Alright, and I'm going to join W and A. Alright, remember I'm doing this on an electronic sheet. You guys will be doing it on a paper. So if our answers vary slightly, don't worry about it. It also can depend on the thickness of the pencil and the scale that you have chosen, so on and so forth. Now remember, because my scale is 1 centimeter equals 2 nautical miles, which I should actually write here and then not forget about it. I have to double whatever distances I calculate, because my scale is 1 centimeter equals 2 nautical miles. That means my 1 centimeter denotes 2 nautical miles on my scale. Alright, so the first thing that I can plot or measure out is the target vessel's course. So just orient your scale in the direction of WA, going from W to A. So W to A is your target vessel's course. Alright, so measure out W to A and then see what course is the vessel doing. So I am getting 117 degrees true. So target vessel course in my case is 117 degrees true. You guys let me know how much you are getting. All right, if you want to measure the speed of the target vessel, then you measure out WA in distance. So if I measure out WA in distance, what I am getting is about 1.25, sorry, not 1.25, but 1.75, somewhere around 1.75. Now 1.75 ideally denotes 3.5 according to my scale. So what this means is that WA 1.75 centimeters, but in my scale 1 centimeter equals denotes 2 nautical miles. So this means this equals 1.75 times 2, which is 3.5 nautical miles, right? So if you have chosen a scale of 1 centimeter equals 1 nautical mile, whatever you measure, you should be getting about 3.5 nautical miles. Now this 3.5 nautical miles is what the target vessel can do in 12 minutes. 12 minutes is 3.5 nautical miles. So in 60 minutes, how much can the target vessel do? So what I will do is I will multiply 60 by 3.5 and then divide it by 12. Alright, so x equals 60 multiplied by 3.5 divided by 12, which equals to, divided by 12 equals to 17.5 nautical miles per hour. So the target vessel speed, according to me, or according to my plot, and I hope this is correct, is 17.5 nautical knots per hour or nautical miles per hour, whichever you want to confirm. All right, so remember we've got two information already. Another information that you can draw is the final bearing of the target was 355, that you know already. So 355, so remember the first bearing was 351 and the next bearing was 355 degrees true, right? So 351 is what you got at 0640 and 355 is what you got at 0652. So it means that from 351 to 355, if you look at this arrow here that I'm showing, that means the bearing is closing towards your course of 042. Remember, you are going on a course of 042 and the bearing is closing from 351 to 355. That means the bearings is moving towards your vessel's course. So in this case, what we say is that the bearing was drawing forward. Bearing was drawing forward towards the vessel's course. That's what we say. So if the bearing was the reverse, if it was opening up from 355 to 351, then we would have said that bearing is drawing aft, but in this case bearing is drawing forward. All right, the range of the vessel you can measure out is from A to C. In this case is 7.1. How I know this is, of course, because the first bearing was at 11 nautical miles and the second bearing was at 7.1 nautical miles. So the target is the range of the target. The range of the target is 7.1 nautical mile, and the final bearing of the target, final observation was 355 degrees true. The bearing was drawing forward as the bearings was closing towards the target or your own vessel's course. So we can say that the bearing was decreasing. That means it was drawing forward. That means the bearing was coming close to your vessel's own course. All right, then we will calculate the CPA and time to CPA, which is the most important bit. Now CPA, and I want to erase the rest of it. I hope you guys have noted it down. So as you know, CPA stands for closest point of approach, and TCPA stands for time to closest point of approach. What does this mean is that when the vessel will be passing your, when the target vessel will be passing your vessel, what will be the closest distance between the two vessels, and how much time will it take for the vessel to reach you or to pass you, and how close will you be passing to these two vessels. So these are the two information that we can draw, and we can draw that very quickly and very easily. So I will again change the color of the pen. I will try to use the pen green color. So what you basically have to do is, you see the line that I have extended from 0 to A and passing in front of C. This line here, you see this line here. All right, so basically you have to measure out, just see what course this this denotes. So it denotes a course of about so O to A. So basically this course denotes about 185 or 186, in my case 186. So basically I have to draw a line perpendicular to this red line here. So this red line which is extending to green line here, I denoted with the arrow. So draw a perpendicular line. So how you can draw a perpendicular line is basically you know that the line OA extended is about 186 in my case. Okay, 185, let's say 185 to 186. I'm getting 185, let's say 185. So a line perpendicular to 185 will be 185 minus 90. So 185 minus 90 will be 9.95 degrees. So you can just draw a line. I'm just showing you the easy way of doing that. So 095. So just draw a line perpendicular. Doesn't matter how you draw it. I'm just showing you an easy way of doing it. So you draw a line perpendicular from C. See this green line here? So this is a line perpendicular to the closest point of approach. Now in this case, this is the CPA, the distance C to the perpendicular. So in the books it's called N. This point is called N. So if I measure this CN, distance CN, what I am getting is 0.55. So CN, according to my scale, is coming out to be, let's say, 1.1 nautical mile. Alright, so why I was getting 1.1 is because I measured out 0.55 centimeters and my scale is 1 centimeter equals 2 nautical miles. I keep repeating that because so that you guys don't get confused. So I'm getting about 1.1. Let me just measure it out properly. Maybe I've got something wrong. It's actually not yeah, it's actually, yeah, so OA, if you really measure out OA, 1.6, so that's what the difference will be, because I'm getting 1.1 and the answer in the book will be 1.4, which is fine, because when I did it on the paper I was getting 1.4 again because of the scale that I've chosen, and it's an electronic sheet, but I'm just showing you the method here, so this should be fine. So this distance CN equals your CPA, which in my case is of course 1.1, but in the book if you compare the answer it is 1.4. so if you take a bigger plotting sheet and you choose a scale of 1 centimeter equals 1 nautical mile, you will get 1.4. don't worry about that. All right, so because I've done this question before, I know that that's what you will get. All right, now we can do time to CPA. So in this case, time to CPA. So let's do time to CPA, and I will choose so time to CPA or TCPA. So to measure out TCPA, what you are basically doing is that you are calculating how much time will the target vessel take, or with respect to your movement, of course, this distance here, AN. So AN divided by OA. So OA is the distance covered by the target vessel in 12 minutes. So if OA is the distance covered in 12 minutes, how much time will the target vessel take to cover the distance in AN? So that's what basically we are calculating. So AN by OA multiplied by the 12-minute plot. Alright, so in other words, you can say if you are covering OA in 12 minutes, how much time will it take for you to cover AN? And then you do a cross multiply, something like that. So that's what is explained here. So AN by OA. So in my case, AN by OA. So if I measure out AN using the scale that I have, again my answer will be slightly different, because so what I am getting AN as, let's see, AN is 1 2 3 3.5. So I'm getting 3 points. So AN I'm getting is 7 nautical miles, and OA we know OA already is 4.1, because 11.1 multiplied minus 7 or sorry 11 minus 7.1, whatever it is, so it's 4.1. OA is 4.1 multiplied by 12. So if I multiply 84 divided by 4.1, I get 20.5. So 20.5 minutes. So it will take the vessel 20.5 minutes, target vessel, to cross you. And now remember that 20.5 minutes from 0652. All right, so 0652 is when you observe the vessel last, plus 20.5 minutes. Let's make it 21 minutes for ease. 21 minutes. So that means that your vessel and the target vessel will cross each other at 0713 hours. All right, 0713 hours. So when you observe the vessel, target vessel, at 0652, and then it will take another 20.5 minutes for the target vessel to cross your vessel. So time to closest point of approach is another 21 minutes almost, and the distance will be about 1.1 nautical miles in my case, and in your case it might be slightly different, 1.3 or 1.4 nautical miles. So that's another information, important information received already. And the final thing that I will show you now is to find the aspect of the target vessel. So again, aspect is also very easy. Sometimes some people get confused, but I explain, or I understand it myself very easily, so I'm going to explain it very easily to you as well. So basically, to find the aspect of the vessel or aspect of the target vessel, you first have to determine whether it's going to be green or red. So green or red, green or red, green or red, green or red. I'm just saying that because I'm erasing the sheet. So how do you know whether it's green or red? So the first thing that you have to see is how is WA going. So you can see that this from WA. So if I just extend it, WA, just going to choose a yellow color pen this time, so that maybe it will help. So if I just extend WA, that is how we are saying the target vessel is going, right? Now if the target vessel is going this way, the center, the C, is lying on its starboard side, right? You are lying on the starboard side of the target vessel, or the movement WA is lying on the movement WA, and the C is on the starboard side of the target vessel. So target vessel is going this way, and C is lying on the starboard side. C is lying on the starboard side. So first your aspect becomes green. So that means you will be on the starboard side of the vessel. So what is aspect? Aspect is your relative bearing as seen from the target vessel. So relative bearing of your own ship as observed from the target vessel. So the target vessel is observing you. You are on the target vessel's starboard side. All right, you are on the target vessel's starboard side. That is first thing. And aspect means what is the relative bearing of you as observed from the target vessel. So what you basically have to see is that you know that the course of the target vessel in this case. So the course of the target vessel, you know. Now what you have to do is basically see the course AC. So you see A here and C here, right? So measure out the course, or rather see what course is A to C. So if I draw a line from A to C, A to C. Okay, so because I'm working with electronic sheet, guys, sorry if my answers don't match yours. So A to C, if I have to measure out A to C, I'm getting about 176. All right, so course A to C is 176 degrees true. All right, 176 degrees true. That means that is the way the bearing of C. So your own ship is bearing 176 degrees true, A to C, going from A to C. That is your bearing as you are seeing. So your relative bearing, or the bearing of your own vessel from the target vessel. All right, but the course of the target vessel that we found out earlier, which is WA, which is the course of the target vessel, WA, all right, was 117. So WA is going 117 degrees true. All right, but the bearing that the target vessel is getting off you, A to C, is 176. All right, but W to A, or target vessel's course, is 117 degrees true. Now what is aspect? Aspect is this angle here. This angle here is aspect. Now you are on the starboard side of the target vessel, and this angle can be measured out by subtracting 176 minus 117 degrees, which is about 59 degrees. So we say that the aspect of the vessel is 59 degrees green. Because green, why? Because you're on the starboard side, and 59 degrees is the angle that the target vessel's course is making with the target vessel's bearing of you, as measured from the target vessel's bridge. All right, so this was a basic plot, and this is all the information that you need to provide. I'm sorry, I have a small plotting sheet here, electronic plotting sheet, but I have shown you the process on how to do the calculation. I will take up more examples and make it complicated as we go forward, but I hope this video helped. Thank you for watching, and subscribe to my channel, share the video. The idea is that we can all learn from one another. Thank you, guys.